hello everybody. Again, for people on Zoom, my name is Miranda Connelly, and I am the current president of SOAR Scholars of Academic Research. Welcome to our second night talk of the semester. So I do have some housekeeping before we begin. I would like to ask,
Sorry, I don't know if your mic's on.
it should be on, but it's not going to hear in the room. It's just really for people.
Oh, it's just that. Okay.
I'm just going to project and use my theater voice for everybody in the back. All right, so the housekeeping before we begin, I would like everyone to please silence their cell phones and also, if possible, refrain from taking any flash photography or video. This Zoom is recorded, so if you do happen to want to watch it again, we will be posting it on our website, and then obviously people will have access to it later. So also, just so you know, this is also for people on Zoom. There will be a dedicated section at the end of the talk to ask questions. And then for people on Zoom, you can put your questions in the chat. And also just remember to please sit back and enjoy some pizza and learn about some neuroscience. So tonight we have the honor of hearing from Dr. Christopher Evans. He received his Ph.D. from Imperial College in London, conducting his thesis research on endorphins and enkephalins. After a postdoctoral fellowship at Stanford University, Dr. Evans joined the UCLA faculty in the Department of Psychiatry and Biobehavioral Science. His research accomplishments have included identification of a number of novel endogenous opioid peptides, or endorphins, and the cloning of the first opioid receptor. Dr. Evans was director of the UCLA Brain Research Institute from 2004 to 2017, and is the Stephan Hattos Professor directing the Shirley and Stephan Hattos Center for Neuropharmacology at the UCLA Semel Institute. Dr. Evans is also the director of a NIH-funded Center of Excellence, the Center for Opioid Receptors and Drugs Abuse, with continuous NIH funding for over 35 years. Dr. Evans was also one of the founders of the UCLA Cannabis Initiative, which now has evolved into a center at UCLA named the Center for Cannabis and Cannabinoids. Dr. Evans is part of the leadership of this cannabis center. Besides continuing preclinical studies on opioids, his recent research focuses on the undergrad-led outreach programs called Drug Outreach Promoting Awareness, or DOPA, a program that has helped create and educate adolescents about drug abuse and drug use. So without further ado, Dr. Christopher Evans.
Okay. Well, thanks for the invite. I'm here really to see my daughter, but this is good. Yeah, so I thought I'd give a sort of quick overview about the opioid system and how we think about it as creating addiction, why it's so addictive, why so many people are dying in the United States from opioid overdoses. And then I'll go over our outreach program so you get an idea of what we're trying to do to help, which is not really sure if this is helping yet, but we'll see. Anyway, I'll start with the opioid system and where it all started. Yeah, well, it started with the opium poppy. You know, the truth is, I do not know if we would know about opioids had it not been for the opium poppy. We wouldn't have known what opioid receptors actually do. It was only because, you know, there was morphine from the opium poppy, and that we really know what the opioid receptor does, because that was the starting point for us to understand the opioid system. Okay, it was because of this opium poppy here. Now, there's a lot of drugs which you'll probably recognize which come from the opium poppy, derived from different metabolites from the opium poppy. What you probably didn't know, and what's covered up there because the live transcription closed captioning is covering it, is a very important fact, is that the morphine in the opium poppy actually is derived from tyrosine and dopamine, which is kind of interesting, and you probably didn't know that, but it's one of the metabolites of dopamine in the poppy. And you get these condensation products which end up in thebaine. And thebaine is the starting product for a lot of opioid drugs that we know of. Oxycodone, hydrocodone, oxycontin, hydrocodone, Percocet, Vicodin, all of these drugs which you've heard of, which are opioid drugs, right? They're all derived from thebaine, which is found in poppy. You've also probably heard of codeine, which is found in cough syrups, and it's also used as an analgesic. But it's kind of interesting because it's a prodrug. It has this little methyl group here, right? And that needs to be taken off before it's actually an opioid. And a lot of people actually don't have the enzymes to actually do that very effectively. So a lot of people don't actually feel effects of codeine. Maybe 10% people, codeine doesn't work as an opioid. So that's pretty interesting. Now, morphine here is the prototypical opioid drug. That's what we use kind of as our standard opioid drug. Heroin is the acetyl form of morphine. So it has two acetyl groups on these hydroxyls here. A little bit more hydrophobic, crosses the blood-brain barrier a little quicker. And it gets deacetylated in the brain and forms a potent drug. But heroin itself does not bind to opiate receptors. It's a prodrug, right? So it's not really an opioid itself. It has to be converted into morphine first. Okay, so these are the drugs that really led to the identification of the opioid receptors. No, well, that went fast, didn't it? Okay, and that's really irritating. That little like transcription thing. It's got all.
You want me to get it? I got it.
You need to get rid of it. Okay, so it turns out that actually, when I first went to UCLA, John Lipsky was my mentor actually, and he worked on pain, and he was one of these big proponents for treating of pain. And the reason was he was doing these animal studies where he was injecting cancer cells into animals, and he was looking at metastases, and he found that if he had the animals in pain, then the metastasis was much worse. So if he treated with opioids and took away the pain, the metastasis wasn't so bad. So his research was really pointing to we have to treat pain. We've got to treat pain. It's very important. And so he was a big proponent of treating with opioids and thought that pain was undertreated in society, which it is. I mean, pain is a big problem. And there was a sentiment then, because everyone was scared of using opioids, that there was this word called opiophobia, right? People were scared of using opioids for treating pain. And in many ways, opioids are pretty safe drugs with regard to physiology, except for the fact that they cause respiratory depression. But in other ways, they're pretty safe, like on the liver, most of them. And there's a lot of evidence for organ damage. And tolerance could be sort of controlled by mixing with other drugs and stuff. So, you know, there was a big push in like 1990 to 2000, a big push for treating patients with their pain with opioids. And of course, you know what happened? It wasn't good. There was a lot of overdoses. And this is just a study from some of my colleagues at UCLA. Ian Sir was the main lead here. But what they found was that this was a cohort which had opiate use disorder, that were diagnosed with opiate use disorder in their data banks, and they found that most of the people started with pain, then transitioned to opiate use disorder, and this was sort of indicative of the problem. But they're being once they were treated with these opioids, they became you know, this was a trigger for their pain. This was the trigger to go into to develop opioid use disorder. And I'm going to get into that a little bit later, what I think are the main reasons why this happens. And we'll go back to this slide in a while. So here is the different phases of the opiate crisis that we're in now, and I hear it's here as well, right? It's not just in the Rust Belt, which was the problem for a long time, but it's sort of spread everywhere. And I'll show you some of the more recent data. But this is kind of how it evolved 2000 till 2016. It sort of started with, I mean, it sort of started with this use of sort of synthetic opioids for pain, and then that sort of leveled off when they started getting in sort of 2014, when they started getting an idea that these sort of synthetic opioid drugs, which were being used for pain, were becoming addictive, and people were overdosing on them. So, you know, they started curtailing people's prescriptions for opioids. And of course, they were already addicted to these things. They went on the street and they got their opioids from the street. And that caused this big increase of heroin, okay, when they couldn't get their opioids from the medicinal therapeutic opioids. So there was a big overdose with heroin. And then, of course, fentanyl came onto the picture. Fentanyl is a much more potent opioid than heroin and morphine. It's about 100 times more potent than morphine in most assays. And actually, fentanyl is kind of pathetic compared with some of the other drugs that are made. There's this drug called etorphine, which is about 1,000 times more potent than morphine, and is very, very, very deadly. But there's also a number of fentanyl derivatives which are much more potent than fentanyl itself. So now fentanyl is turning up in everything, right? And it's a really big killer. So this is what's happened in the last few years. There's now over 100,000 deaths because of drugs of different sorts, and about 80,000 of those are due to phenols and fentanyl derivatives. So opioids and fentanyl derivatives, and the psychostimulants, as you can see, meth coming up. People are using much more meth now, and so the psychostimulant overdoses are becoming problematic. People are sort of going between the two. So we're really in a mess when it comes to drug overdoses, and it's kind of sad, and it's gotten much worse because of COVID. Now, there's some good things which have happened in the statistics with the COVID. There's much less initiation by the high school kids, which is good to hear. That's presumably because they're not going to school, right? They're stuck at home. They haven't got their peers to get their drugs from and share ideas from. But there's the statistics actually during COVID have been terrible for opioid overdoses, really terrible. So let's talk a little bit about the opioid system, what it is. I realize that you're mostly psychology, right? So you're not pharmacologists, or so I'm going to see some blank faces. It's all right, don't worry. I'm actually a peptide chemist by training. I'm a peptide chemist, so I know a lot about this stuff. And these opiate receptors are actually very, very similar to the cannabinoid receptors in your brain, almost identical. Okay, they're G-protein coupled receptors, and what they do is they inhibit neuronal firing. So if you activate those receptors, the neurons shut down. Okay, that's all you need to know. And in the case, oh, wow, it's all happening automatically. Okay, so that's good. Okay, so there's glycosylation there, which you don't really need to know. There's these intron exon boundaries, which you don't really need to know. I'm only telling you this because it'll come back when we start talking about the evolution of these systems. And the peptides which activate these receptors are called endorphins and encapsulins. And you've heard of endorphins, right? You've probably heard a lot about endorphins because the runner's high and all that. I don't think it's right, but it's you know, people like that story. But there's these endorphins are in the brain. These are the natural ligands for. There's a natural ligand in the brain which actually activate these receptors. They aren't like morphine, they're peptides, they're small peptides. And they're derived from these big precursor proteins. They're sort of chopped up by these enzymes to form lots of different opioids. And this is what I was working on at Stanford. I was isolating the different opioid peptides which are formed by from these precursors. So there's nearly 30 of them in the brain. There's lots of different opioid peptides in the brain, and they all work on these receptors. And there's 3 of them. Did that all happen automatically? I guess they try to keep me to time. Anyway, so there's all these different opioid peptides here on the left, and they all have different affinities for the different opioid receptors. And that's you just got to know it's kind of complicated, but it's kind of important because all of those opioid receptors look pretty similar, right? They're all pretty homogeneous. I'm going to go back, see if it'll let me go back. Yeah, it does. So all the receptors are pretty similar. So the red are like between 75 and 100% identity. That's identical amino acids between the receptors. The orange is between 50 and 75%. So these are very, very similar receptors, okay? And there's lots of different peptides, but these receptors do very, very different things. So, and they're very different, okay? So if we look at the mu opioid receptors, these are the ones which if you take fentanyl, you're overdose on. There's the mu opioid receptors. So if we take, we have mice which don't have opioid receptors. We've genetically engineered them so they don't have opioid receptors. They will not show any respiratory depression. They won't show any reward for morphine, and they won't show any of the constipatory effects either. So all of the effects that we know about opioid drugs really occur via the mu receptors. The analgesia, the rewarding effects, the antitussive. Anyone know what antitussive is? It's like codeine and morphine. That's why you have codeine in cough syrup. It's antitussive. Okay, and then the respiratory depression, which kills you, the constipation, which drives you nuts, because you can't poop, and some people get nausea. Now, some people really hate opioids because of the constipation and the nausea. In fact, you know, I've spoken to people who really can't bear being on opioids, and other people who really love them. So it's a bit of a crapshoot there. Now, that's the mu opioid receptor. That's the one which you would identify with all the effects of opioids that you know of. But there are 3 other ones. And the delta opioid receptors, these are the ones we cloned first. They're kind of interesting. If the agonists, the drugs which activate these receptors, show analgesia, but only analgesia when you have chronic pain. And they're only rewarding in chronic pain states. Problem with these is they're seizure inducing. So at least some of them are. And I can't get into agonist-directed signaling because that's a bit beyond us, but some of the drugs actually cause seizures subdoned. And the important thing here is they're anxiolytic. the agonists. So they prevent anxiety. Now I want to go to kappa receptors, and this is so interesting. Okay, I told you that these opioid receptors are almost identical, but look what kappa receptors do. They're aversive when you activate them. People hate it. Well, most people are like, I shouldn't really ask, but how many of you tried salvia? I know it's legal. Yes, but probably quite a few of you. Salvia is a very potent hallucinogen, and if you ask people, I've had grad students who have tried it, and they said the worst experience of their life. They really do not like it. They feel they've been taken into hell. I think he felt he was a little piece of dirt and he'd been trodden on by somebody. So that was his salvia experience. But I've had lots of bad experiences with that. Some people love it, right? Some people actually do get almost addicted to salvia, but it's pretty rare. And it turns out that salvinorin, which is in salvia, is a very potent kappa agonist. So that's how it's working. That's how it's producing its hallucinogenic activity through the kappa receptor. And then this ORL1 receptor, which we also clone, nobody really knows what it does. It's actually much more abundant in the brain than the mu receptor. There's many more receptors, but we just don't know what it does. And that's one of the problems, right? There's a lot of orphan receptors in the brain, which we don't really know what they do. And that's what I was saying in the beginning. If we hadn't have had morphine, we would probably not know what this mu receptor actually does. It's only because there was morphine. Okay. I think that's what I wanted to say about that. Okay, so this is the distribution in the brain of the different opioid receptors. The mu opioid receptor is in lots of different areas. They're all actually found in lots of different areas of the brain. But the mu opioid receptor is pretty bad because it's in those centers which control breathing in the brainstem. And that's why you stop breathing. Well, that's one of the reasons you stop breathing. I think there's also receptors which control the diaphragm as well. So that it may be that there's multiple ways that it actually does cause respiratory depression, but the mu, delta, kappa, and ORL1 all have very, very different distributions throughout the brain, and that's why they have such different effects. So this opioid system has very, very interesting. That's interesting. This came up, it doesn't come up there. Very interesting different effects of the different opioid receptors. Okay. There we go. Okay, so as I said, we can make mice which don't have these opioid receptors. Okay, we can just take them out of mice. So these are we just make a mu receptor knockout, a delta receptor knockout, a kappa receptor knockout. And I only really want to tell you about the mu receptor knockout because I think that's the interesting one. If you take away the mu opioid receptor away, these animals have much reduced rewarding effects of THC, alcohol, and nicotine. So they basically lose the rewarding effects of some of the other drugs. And that's kind of interesting because, you know, we have drugs to block opioid receptors. So one of the drugs to treat alcohol use disorder is naltrexone. And you've heard of naloxone, I'm sure, right? You know, because when you go to overdose, you have naloxone. Now, naltrexone is like naloxone, except it lasts a long time. And that's used for alcohol use disorder, and it kind of reduces the rewarding effects of alcohol. Now, I'm not a big fan of mucking around with reward systems to treat addictions, because I think one of the problems with addictions is that people get dysphoric. They don't appreciate life. They They get anhedonia, which is the lack of appreciation of rewards, like food, like living, like relationships. All of this goes. So I'm not a fan of actually blocking reward pathways for treating addiction. I don't think it's the right way to go. I think they need to be re-educated. But one of the treatments, as I say, for alcohol is naltrexone, and it's accepted by the FDA for that. Now, the kappa receptor knockout, they actually have decreased, they have decreased dysphoria with THC. So, you know, THC can sometimes cause a lot of anxiety in high concentrations, right? You've probably seen some people have that problem, rush to the emergency room, and it happens quite frequently. That's one of the problems. And the kappa receptor seems to be involved in that kind of aversive sort of state which happens with increased cannabis. So anyway, just a few interesting little things about these opioid receptor knockouts. Okay, so what about the drugs we know of? This is fentanyl, and the real problem with fentanyl is damn easy to make, right? It's really easy, it's very potent, it's easy to make, so all these clandestine labs can make it very, very easy. These drugs like morphine, this is morphine, buprenorphine, which is used for treating those with an opioid use disorder. Maybe it's going to be treated for, maybe it's going to be more of a treatment for pain. In Europe, it's used for treatment of pain. Morphine was that one I showed you, it was really potent. That's the sort of, that's a derivative of morphine, yeah, sort of morphine-like structures, then the oxycodone and hydrocodones. These drugs, like fentanyl and methadone, really easy to make, very cheap. You know, it's a problem, right? I mean, if you can make these in a clandestine lab, and you know, the chemists have published all these beautiful papers. How do you make fentanyl easily? Because you know, it was part of, you know, academia is to try and develop, you know, mechanisms for making these drugs, and they publish them, and of course other people can copy them. You probably know the same things have happened with spice, with all the synthetic cannabinoids. You know, it's academia of trying to make ligands which are high affinity for the cannabinoid receptors, and they've been very successful. And then, of course, clandestine labs try to make them. They make them a little bit wrong, and you have zombies, and you have all sorts of things go wrong, because these are not drugs which have gone through any clinical trials, or they know actually quite how they work. So it's a big problem. So the synthesis of drugs has been a big problem. Well, you know, in some ways you wish you could go back to where people were sucking cocoa leaves and smoking a little bit of opium here and there. Wasn't too much of a problem. But now everything's been purified and optimized, and there's drugs which are much more potent. That's where the problems are coming. Okay. Okay, this is the torpine. This is used in these elephant guns. And it's one of the drugs I played around with quite a lot, because it sees all the opioid receptors, all the different opioid receptors, and it's a very interesting drug, but very, very potent. This one's about 1,000 times more potent than morphine. So you don't need much of it in those guns to knock down elephants. Okay. Okay, not bad. Okay, so I have, you know, one of my interests, one of my hobbies, one of my things that I'm not getting funded for is how do systems get put together? How does the opioid system get involved in these things like analgesia? How does it get involved in the reward? How does it get involved in affect? How good you're feeling? How does it get involved? How did evolution I hope everyone believes in evolution. Should last us. Maybe should. Yeah, we're getting weird politics these days, and you don't know what's going to happen. Anyway, I'm interested in how this evolves. So I went back and I tried to figure out how the opioid system got put together. So I did this first with the receptors because they're pretty homogeneous. And the only systems I could find with opioid receptors or opioid peptides was in the vertebrates. And the lowest vertebrate I could find was this hagfish. Anyone know what hagfish are? You know what hagfish are? The slime. Yeah, they're pretty cool things. I'll show you a little video of one. Here's a little video. Okay, this is what they look like. They're jawless. They have no bones, right? They live pretty deep. They live about, they live up to like 5,000 feet deep. That's pretty cold down there and pretty high pressure, right? So they live pretty deep. They're pretty ugly. They have 5 hearts, and they have this incredible slime. You touch them, and there's this slime just dribbles everywhere. And yeah, they're kind of ugly, like aliens, right? And about 80 different species, and they do something very weird with DNA. They're one of the only species which as the cells divide in different areas of the body, they throw out genes. And not many other species do that. So I mean, it's kind of a waste of time having all the genes in every cell, right? And they formed a mechanism for just throwing out genes when they didn't need them. So it's pretty cool. Okay, so this is an old fossil of one, for those who believe in evolution. And this was found in 100-million-year-old rock, and you can see some of these slime glands were actually in this fossil. So that's pretty cool. I like fossils. Ever since I was a kid, I've been collecting fossils. That's Zen knows. Anyway, let's see if this works, shall we? Okay. So this is this slime is pretty effective. Look at this big old shark gagging. And then this is another one. See that little gonna have a go at it in a minute. Oh. So I think there's another one here. It's kind of fun to watch these. I don't know if you've got enough time, but whatever. Yeah. The fish don't have a chance. They just gag. So it's an amazing system that they've developed to prevent being eaten. Pretty cool. Anyway, okay, so what I did was it's pretty easy these days to take the DNA and make libraries. We made an RNA library and DNA library, and we found many different opioid receptors there and many different opioid peptides. But it seems very interesting that this was the first time in evolution we could find these receptors and peptides. So then I thought, well, how could this evolve? From what could this have evolved? So I then asked one of my students, so this is all of the receptors. The receptors look very much like the human receptors, and the peptides look a little bit different, but the precursors are there. There's like 4 of them, 4 different precursors we found. And so I started looking in the literature. It turns out that a number of peptides which are derived from these opioid precursors are actually antimicrobial. So they prevent microbes from growing, like bacteria. And that got me thinking, well, maybe these peptides sort of were originally secreted when the animal was trying to get food, because that's kind of dangerous with hunting, or when it was mating. So it was after rewards or was feeling bad. So it was having pain, right? So there was lots of times that these antimicrobial peptides may be secreted. So my theory began to sort of form that maybe this was derived from an antimicrobial system. So then I asked my students to have a look for a few homologies, and geez, did I have it automatically? I didn't touch it. Anyway, so there's this family of antimicrobial peptides called defensins. It's a whole bunch of them. And they're found in everything from plants to all plants and animals, and they really protect against bacterial growth. So this was a very, very, very crude sort of immune system, one of the first immune systems, these antimicrobial peptides. So I was wondering if any of them were comparable to our opioid precursors. And lo and behold, right in the center of the defensin 5, this is the homology. This is really quite high homology. So in my view, and my thoughts are that maybe this opioid system actually evolved from an antimicrobial system, one which is antimicrobial peptides. Can't prove it yet. I got to do a lot more work on that one, but you know, nobody's giving me any money for it. So, but if you notice, these cysteine, all these cysteines are there. And anyway, that's one comment I wrote about it. So anyway, I'll recite it. Hunting food or getting a mate is a risky business that one must partake. And just in case one should get hurt, a peptide cocktail can be spurred. The bugs are killed by the peptide mix, then roles are linked to getting that fix. So now the peptides gain a meaning for rewards and pain and even feeling. So there you go. That's my theory, which is mine. Okay. So I told you I'd come back to this slide because we were talking about those with substance use disorder and how it evolved from opioid use disorder and how it evolved from being treated with pain with opioids. And what I want to show you now is the rest of that data, which shows the high comorbidity with depression and anxiety. So really, and if you really look in, and this is a very well characterized cohort of people. They, you know, they're in the system, they have money, so they can go to their doctors when they're sick, and they have health insurance, of course, because this is where the data comes from. Up to 81% of those with, you know, this is any mental disorder, have a comorbidity with a mental health, opioid use disorder with a mental health disorder. So that's a very, very high percentage. And if you look, most of this is anxiety and depression. Now, this is, I know, a very, very simple slide, but I think it's very important that when you take opioids, you know, you have a certain set of things happen to you. Usually, you're relaxed, you're mellow, pain goes away. You have constipation, but that's all right. You're feeling good, you may be sleepy, right? Now, coming off opioids, especially if you've had them for a long time, you're anxious, you're agitated, you're down, you're dysphoric, you don't appreciate other rewards. Diarrhea, exactly the opposite effects. Pain sensitive, disrupted sleep. So you can imagine if someone has anxiety or depression, that this state is going to be absolutely unbearable, right? And if you've gone through a few cycles of taking opioids and then going off them, you've learned that those opioids are going to take you out of these states. So there's a learning component, right? Association of the drug with relief of anxiety, depression. You associated the drug in your brain with these conditions. So this is Kathy, my wife's up there in the back. We wrote this review together, and I mean, it's pretty simple, but I think that it wasn't really clearly stated in the literature. That this was a story we developed about, I don't know, it was what was it, some well, I've forgotten what we had. We had she was trying out for some game or something, some cheer. She's going to be a cheerleader. That's what it was. She was going to be a cheerleader, right? So and she sprained her ankle and she hurt her ankle, right? And so she was a bit depressed about that. And she knew her brother had, just had his teeth out. But he didn't kind of like the Vicodin, so she went in and got the Vicodin from the cabinet, right? And she took the Vicodin, took away her pain, and she felt much better, right? Her mood went up because she was taking the opioid. But of course, the next day, her mood went down again, and she took another Vicodin. And after a week, gradually, the effect was a little bit less, and the pills ran out. But she learned what that pill did for her. There was a learning phase. It's a learning phase. It's the learning what the opioid can do for you. It took away her anxiety. It took away her depression. It took away her pain. So she went through withdrawal, but then she had an anxiety trigger. I think she broke up with her boyfriend or something. It was something like that. I don't know. But we had a bit of a trauma, and she had stress, right? And this, of course, made her crave because the association of the anxiety state was with the drug. And then, of course, she didn't have any drugs, so she went on the street and got what she can. And of course, so easy to get the wrong stuff because you don't know what's on the street. There could be anything, right? And with fentanyl, it's very easy to look at. So really, it's all about the development of the learning curve. The learning curve that the brain is changing. When you go through withdrawal, that the brain has actually changed because there's a withdrawal state. But you can relieve that with the drug, and then it becomes a generalized association with the relief of anxiety or depression. And I think that is a major reason why people get stuck with their opiate drugs, because life is very anxious, anxiety driven at the moment, and it's very easy to get the association of relief with the opiate drugs. So, okay, so this is basically really talking about this, and this is the figure we had that and really just saying that there was many ways to relapse. One of them is just the withdrawal symptoms themselves. The withdrawal symptoms themselves can be relieved by taking the drug again, but there's also a memory process which can be affected when any life stress event will trigger craving because the association of relief of the oh geez. Okay. I think I only have a few more slides. We'll go through fast. Okay, so okay, so I've done most of my work on animal research, and I got a bit fed up of it because I don't think I'm gonna do any good. So I really would like to sort of do some translational stuff. So I have a program which I'd like to share with you because I think it works, and it works well for everybody involved. And I'll tell you what it is. Okay, so this was my intro into This was my daughter's brain when she was young. This is Anna when she was like 6. 1, 2, 3, 4. Yeah, she was 6. Yeah. Her birthday. So I took a picture of her and I put a real brain in her. Not that you haven't got one. But I stuck a brain in her. And this is for the kids. And I wrote another poem, but I don't know if we got time for it. But you can see it another time. It'll be on the recording. But anyway, what we developed was this outreach program called DOPA. So I have a class which teaches people how drugs work, and we talk a little bit about the physiology of the drugs and the pharmacology of how drugs work. And then we this is for undergraduates, and then we have a capstone project where we teach a capstone team to go to the schools, and they develop these activities which sort of try and convey a couple of things about drugs. Very simple things. You don't know what you're getting. Mixing drugs is a big problem. The employment process is that when you stop the drug, it's always going to be opposite of taking the drug. Those are some of the very, very simple messages we try to get across. Now, undergraduates going to high schools have it's a big difference from me or policemen going to the high school.
I need to go back.
Your slide changed. Did it really? Wow, let's do that. We must somehow have gone to some automatic system. Anyway, you know, undergraduates are much more likely to be listened to by high school kids than policemen, for sure. And even me, they don't listen to me. You know, these guys are able to convey the problems. They listen to them, and it's such a difference to see this happen. So what we did was as I said, we teach them about drugs. We teach our undergraduates about drugs, and then we have these little teams. We have 4 teams. We have one on prescription drugs, one on cannabinoids, one on legal drugs like alcohol and nicotine, and one on prescription drugs. So, and then the kids go around these little activity stations. So you have little games and things like that, and they all get engaged. They will love it. Well, it's all right. This is fine. This is fine. Well, it seems that they understand that there's, you know, statistics is weird, right? You can. It's getting faster and faster. I mean, I don't understand this. Okay. Anyway. You know, we had decent statistics to show that, you know, the high school kids were getting some messages out of that. I'll give up. Anyway, the statistics look good, okay? But I mean, you know, they were generalizing as well. I mean, we never told them that you know, mushrooms, for instance, would be addictive in any way, but they kind of assumed it, right? So there's some generalization going on, but in the long run, they seem to be considering. These are matched students because we were able to match them by very random things that we asked them, but we were able to. I think one important thing, we were able to convey the harm of spice. They did not know that synthetic cannabinoids were the same. They always thought they were just like cannabis. So we did some good there. We were able to convince them that they were bad, and they did understand by the end that that spice was a bit of a crapshoot, whereas THC, you know. But with THC, there was not much change, actually. We weren't able to change their opinions. So much education about THC, it's not really a problem. That we couldn't change. The only difference we got between males and females was with alcohol. Males didn't think that alcohol was addictive, females did. But after our visit, the males went up to the females. Kind of interesting. But anyway, we did this online and that kind of work. We have these little games which we played. So we did it, and we actually have a publication on this if anyone's interested. But it really does work well. The students love it, the undergraduates love it because they learn about drugs, and they go to the schools and do a bit of outreach and feel they're doing good. And the high school kids love it, and the teachers love it. So they all seem to be good. And I'm about right, right? There you go. Well, now we go on for any questions.
So what are, so we got to the past here. Like this one. So we do have this fancy mic box, so everybody can hear us. And if anybody has any questions for Dr. Adams? Anybody? Yes. Oh, yeah. Want to pass it? Anybody?
All right.
I don't know if it's possible to get high from the hagfish slide.
Asphyxia.
No, I haven't serious testing though. How do those ancient opioid peptides kill bacteria? I was specifically wondering if bacteria have a receptor for the peptides and the.
No, it's not the opioid peptide itself, it's other parts of the precursor. Now, there is one opioid peptide which is phosphorylated. There's a phosphorylation of the peptide, so it makes it very acidic. And very acidic peptides seem to be antimicrobial. So that's how it works.
All right. More questions? Pass the box around. Over, right up there. Yay.
I was curious about the early graphs on the fentanyl overdoses with for the fentanyl overdoses also under, like, if meth had been contaminated with fentanyl, or if another drug had been contaminated with fentanyl, was that under fentanyl or was that under like methamphetamine?
You're right, how the statistics are gathered for those data. Is that what you're asking?
Yeah, I was wondering.
Yeah, I know. I'm always a bit skeptical about that.
So I feel like whenever we hear,
I mean, I know a lot of people are now using psychostimulants, and they're actually dying from the psychostimulants. And I don't know if it's always spent. You know, sometimes you spend in a land psychostimulants, but it may be that. It may be not quite so clear what drug is involved, because it's, I mean, okay, so let me go back. The many overdoses of multiple drugs, you know, alcohol plus opioids, right? Benzodiazepines, where people are trying to sleep, plus opioids. Very often it's multiple drugs. So it's really difficult to actually say which drug is actually killing them. Now, the trouble with fentanyl, it's got such a small dose range from being high to being dead, that, you know, that's where the problems are. It's a very, very narrow dose response. And you don't need much like benzos to actually amplify the effects of opioids. So buprenorphine, for instance, a partial agonist, although I'm going pharmacology, I'm going to shut, but buprenorphine doesn't, you can't overdose on buprenorphine normally, because it only partially activates the receptor. We call it a partial agonist, right? And that's why it's used for treatments of opiate use disorder, because you can't really overdose on it. But if you add it with benzodiazepines, people can have respiratory depression and die. And that's what's happening in Europe.
There's actually a question in the chat about something related. So what's your opinion of Suboxone, and how can people like actually get free even of that?
Suboxone is buprenorphine.
Okay.
But it's combined with naloxone. And the reasons it's combined with naloxone is quite clever. So the way you take buprenorphine is it's sublingual. You take it under the tongue, and it's bioavailable that way. but naloxone is not. So naloxone won't block the effects of buprenorphine if it's taken under the tongue. But if you inject it, which those with opiate use disorder like to, then it will block the effects of buprenorphine. It's all to do with bioavailability, so it's kind of a clever use of naloxone to prevent overdose. People using it, will abuse it. Misuse it is the right word these days.
Yeah.
Misuse.
And then I hear, well, I'll get to that later. So the other question in the chat is there a way to use opioids responsibly? For example, during a pivotal time, like a death in the family, divorce, could we use these drugs in order to better deal with the situation? Is it be fair that everyone should be restricted to using the drug just because some people have affinity for the opioids?
Yeah. Well, that's a very important question. So I'm going to share something with you. It's kind of weird, but whenever I go through a bad time in my life, I will stop all my drugs because I know that that's what I'm susceptible to becoming reliant on them. You know, it's not the right thing to do. It's really not solving the problem because you're basically then associating your drug with the relief of your problems, and that really becomes dangerous. So, I mean, if people are susceptible to depression and anxiety, I think most of the opioids are dangerous. Some people can, you know, take cocaine one day, fine. They don't care whether they have it next day or not, right? There's only certain people who are susceptible to probably every type of addiction. It's not that you're going to be susceptible to every type of addiction. Some people are going to be cocaine, some people are opioids, some people are sex, some people are going to be something else, right? Gambling. It's going to be something. But not everyone's going to be susceptible to the same addictions. I think that's important. Can you use it responsibly? Maybe people sucking cocoa leaves are using it responsibly. Maybe those who are using cut all the time are using it responsibly. I mean, it's like caffeine. Who uses caffeine? I mean, you know, that's a difficult question because I think it depends on the personality and what you associate the drug with. Very important. Yeah.
We have one more question. Packed out the box. So people want on to
Yeah, so like as scientists who, you know, are potentially going to go into like pharmacology or drug development, is there, you can do is, you know, what is that outlook on like drug development and reducing harm from like drug development? If, you know, you were talking about how like developing these like opioid drugs has like really increased, you know, our opioid use disorder and worldwide. So
If you become a pharmacologist, you're saying making drugs for this, that, and the other, and then creating a drug which may be really going to kill thousands and thousands of people instead of saving thousands. It's a good ethical question. I mean, you know, William Hoffman, who designed all the spice drugs, right? Does he feel guilty about it? I don't think so. I mean, I think his research was genuine. He was trying to find, you know, ligands which interact with a receptor, and he found these drugs. And they just happen to be very potent at the cannabinoid receptor. And those that discovered fentanyl, you know, it's a very effective analgesic for those with cancer pain. So, you know, it's a really difficult question, and it's an ethical question. And I mean, I don't think you can stop science. I don't think you'll ever be able to stop science. I think we need to educate people, and people need to understand the risks, the real risks. And I think we need to treat people as individuals, right? I mean, you know, some individuals are going to be fine with opioids. They're not going to go on to be have an opiate use disorder. Some are. I think it's very important that we treat sort of people as individuals on that. I mean, like, a third of the people who smoke cannabis sort of weekly would be considered to have a cannabis use disorder. There's nothing to kill them. Nothing to kill them. So, you know, is it a problem? I don't know. I think it's an ethical question about drug design, and so you want to be a pharmacologist? Yeah. No, I'm a pharmacologist, and I think there's going to be some good drugs for treatments, but I think we got to treat depression, anxiety. I think that's where we got to go to. I think that's the root of a lot of the issues we have in the world.
And treat anxiety and depression not with drugs, but with like outreach programs. Like,
Well, no, I believe in therapy more than anything. I am a believer because that transfers to the next generation. You're not just you're not using a drug, and you know, every time you use a drug, you have an approval process. The brain adapts to it. And for SSRIs, that's great, right?
yeah,
In fact, there's something you guys should know. The way SSRIs work looks like it's an upregulation of the endogenous opioid system. And this just been published. I just had to write a review on that. So you'll see it in Biological Psychiatry. Just came out.
thank you.
It's an interesting story.
Okay. Take away.
So I think we have 1, 2 questions up here. Any others? So, okay. So we're gonna do 1, 2, 3. And thank you all for coming. You can have to leave. Feel free, this is recorded, so just so you know, but please feel free to stay after the question.
You'll have to speak up.
Go ahead. Hi, so I saw that there was like, we talked a lot about interventions, which you mentioned. I was curious, I'm really interested in looking at adult, changing adult behavior around like misuse of drugs and just like adverse behaviors. And so I'm wondering what kind of research have we seen in ways to intervene in adult life, and what kind of methods can we use to kind of educate adults more like about.
That's right. You have to sort of educate everyone. I mean, it kind of worked quite well with smoking, right? You know, smoking campaigns work pretty well. And there's been a big reduction in smoking, but vaping has gone up like crazy. And cannabis use has gone up like crazy. You know, I had mixed feelings when they legalized cannabis. I must say, I mean, if you compare it with alcohol, cannabis is much safer drug, right, than alcohol in many ways. Well, for most people, but you know, when you legalize it, you kind of accept it. It's considered an okay thing, and it's got problems with it, right? I mean, we know that cannabis can cause some people to go into psychotic states. I mean, it's different from actually psychosis, but it's not schizophrenia, but it can precipitate those states, which can last a little while. And so there are problems. So what you're asking is, how do we educate everyone, and how do we sort of get to a point where people are kind of responsive about it? I mean, I'm a big fan of Portugal, and you know what they did in Portugal? They legalized everything, right? They legalized everything, but they put all of their money into therapy, and they put all their money into helping people with drug problems instead of putting them in prison. And their overdose rates are really, really low. It used to be much higher in the United States. They went down, the United States went way up. Because I think they came to the conclusion they couldn't really stop drug use. They accepted it as part of society, and they had to help the people who were unable to control that use. And in some ways, I feel that's a much better strategy, because you're treating it like it's a disease. You're treating it like it's a problem for some people, like anxiety, like depression, like sort of a mental health disorder. And I think that's probably got much more validity in it than putting people in prison, taking away all of their ability to work in life, making them more dysphoric, and just doesn't help. So it's really societal attitude and laws, which I think are really not helping those who have problems with addictions.
Thank you.
Forward above it.
Thank you for the talk. It's been very interesting, but this must have completely gone over my head at some point, because I was having trouble understanding why those fish were spitting out the worms. I know it definitely has something to do with the slime, but I must have just missed it at some point.
They couldn't breathe.
Oh,
The fish was being suffocated. You want to show your game?
it was quite an.
So basically, what happens is they have all these little holes along their body, and as soon as the shark or the fish grabs hold of them, they immediately release this slime, and it just goes into their lungs, and they just gag. It's an amazing defense mechanism. Really, it's very effective. Yeah.
Like if a fish were to dive into mud and try to breathe, basically.
You just can't breathe.
And that had in part to do with the peptide that was within the slime, basically, or the.
No, the slime is nothing really to do with my story. It's a fun little thing about hagfish.
Oh, okay.
It's really nothing to do with the opioid system. So I wish it was, right? I actually don't know where the opioid systems are in the hagfish. I'm actually getting a friend to go through the hagfish body and brain to find out where the heck they are. So we need to do that. But no, the interesting thing about those hagfish is throwing out the genes. You should look that up. That's really cool that they just throw out genes. Yeah.
That's my question. How do they throw out the genes? Like when?
How they drop it?
Yeah, like is it literally like being expelled? Like,
I think it's when the cells divide.
Okay.
That somehow it's when certain cells divide, they decide after that they don't need that set of genes.
and some other cells will still have that.
Yeah.
same
Like
gene.
the germ cells will start. Yeah, it's kind of cool. Yeah, look it up. It's sort of Nature paper quite a long time ago, but it's very cool stuff.
So we
Yeah.
have another question for you, what for that?
I guess you sort of answered this a couple of questions ago, but since you're not a big fan of blocking the water pathways for addiction, what do you prefer?
Well, I think if you block reward, you block learning process. Reward, like dopamine, you can block dopamine system, right? And you're going to feel dysphoric. You're not going to be anhedonic. You're not going to be able to re-educate the reward system. So, I mean, I see addiction as just a reward system which is not well educated. It thinks that the reward is okay, that I'm going to relieve my depression with an opiate drug. Yeah, it works, but in the long term, it doesn't work, right? So it's an education and reward system. If you block that, then how can you relearn something which does work? So I mean, I consider it a learning problem. Most addiction. I mean, if you didn't remember anything, you wouldn't be addicted, right? You wouldn't be craving something. You wouldn't be addicted. It's a learning problem. It's a problem with associations. That's how I see it anyway. I mean, you know, a lot of people would disagree with me, but that's all right. I don't care.
So,
That's how I consider it.
really fast, just one at the very top.
I can just yell.
Oh, okay.
I was wondering what your thoughts are on something like kratom, just broadly, and all.
Great. Yeah, good one.
Yeah, and people like using it to kind of like wane themselves off of like.
I think, okay. So the problem with most of the drugs which we're talking about with opioids is that you inject them, or you know, it's very rare you're gonna eat them because it takes such a long time to work, right? Most of the drugs which are highly addictive, you're either smoking them, you're vaping them, or you're injecting them, right? And with kratom, it's mostly teas, right? You're making teas, you're making it's for everyone else. There's a plant called kratom, which has a drug called mitagenin, something like that. Anyway, it's an opiate drug, and what they do is it's very popular in some cultures. They make teas out of it, and it sort of takes away anxiety, etc., etc. But it's an opioid. It is an opioid, and it works quite well. I mean, I would say, yeah, try it because you're not going to overdose on it. And I don't see anything wrong with that. I don't see anything wrong. I think that, you know, most things taken by an oral route are not going to be so addictive. The brain responds very differently to something which is orally taken, because it takes like, you know, an hour and a half for it to get usually to work, right? And, you know, people who take cannabis think, oh, nothing's happening. Okay, I'll eat a few more grams. Nothing's happening. Because they've had so many brownies that they've, you know, most of the overdoses they see in the, well, not overdoses, but deaths, but most of the, you know, panic attacks, etc., that they get with high cannabis is because they've taken it orally, taken it in brownies, because they think it hasn't worked, and then it takes 2 or 3, maybe some people it take 2 hours, some people it take 1 hour. It depends on the digestion, right? So, I think kratom is a good solution. And now it's not going to be legal, right? That's not a problem. Legality. And now it is legal in some states. I think I've seen it in North Carolina. It's legal. You can go to the smoke shops and get kratom. But the trouble with plants.
We have it here, actually.
Is it legal here now?
The head shops.
You can get kratom. Yeah. I mean, I don't see anything wrong with kratom. I mean, I see very little wrong with plant products, actually. I think the problem has been these concentrated products, these synthetic products. That's what's really caused the problems with addictions. Not necessarily with addictions, but with overdoses and really debilitating people. That's where the problems are starting.
I think we do have questions right here.
Oh, I want, thank you, by the way, for taking time out of your vacation today.
That's all right.
I wanted to ask a question. I'm afraid it maybe is a little bit uncomfortable, but I was struck by the handwritten edits that you showed, that Liebskin made to that
Yeah.
abstract, because you seem to be sort of dramatizing the problem of pain. Remember, one went from like will be a problem to will be deadly or something.
Yes, yeah, he was very adamant about treating pain. And it was all because of his research with cancer cells and metastases. And it really was not very good evidence, I don't think, that you had to treat pain to to get better. I mean, obviously, when you're stressed, you don't have a lot of corticosteroids, right? And those corticosteroids are going to produce, be immune suppressive. And so stress is not good for the immune system. So you can imagine with some kind of pain developing mechanisms that that you don't actually want to have opioids at all. You don't want to. I mean, you don't want the stress. But in other times, you might want the stress. So maybe you do want to suppress the immune system, like if you have a lot of inflammation. You don't want in a cytokine storm, right? You maybe want the stress.
But the uncomfortable part of my question was he really just sincerely convinced that it was important to treat the pain, or as has often happened in the history of the opioid crisis, there's profiteering along with the science? And was that the case in his
It may have been for self-aggrandizement. It may be because he would have more focus on him. That's a possibility. I mean, scientists, right? They all want to be famous and stuff, and that causes a lot of problems. But I didn't get that feeling from John. John was a very gentle guy. He just really believed this thing. He was a very genuine guy. Nice man. I mean, he eventually died from cancer himself.
I ask because I know that the treat the pain idea is attributed for a lot of the problems that.
Yeah, well, that's I think now we've gone the other way. There's, people are not being treated properly. But I also, we need to find the phenotypes and the genotypes which lead to the addiction, and then we can be much more careful. I think they're already now using anxiety testing and depression testing when they're giving people opioids for chronic pain anyway. So and that has its problems in itself, but it is a susceptibility.
Any other questions?
Go, can we eat?